Okay, girls, I want to pick it up from where I left in the first video. Now, we're at construction of the space diagram. And the entire length of the space diagram given was 16 meters. So we can observe that we have 4 meters, 4 meters, 4 meters, and then 4 meters, making it 16 meters. We cannot draw this length 60 meters on our sheet of paper. And the scale at this side has been given as 1 mm is equal to 0.1 meters. So if this is 4 meters and you have to convert it to millimeters, how many millimeters is going to be this 4 meters? So according to our scale, 1 mm is equal to 0.1 meters. So 4 meters will be how many? So what we do is that it will be more. So if more, let's divide. So 4 divided by 0.1 will give us, I think, 40 millimeters. So the 4 meters in each space will now be 40 millimeters so that it can be constructed or drawn on the sheet of paper. When you move to the vertical height tool, the dimension there was 4 meters as well. So you convert that 4 meters also into millimeters so that it can be drawn. And that one will also be 40 millimeters. When you are done, you join the diagonals. So I do believe that the construction of the space diagram will not be anything difficult to go by. Now, we're done with the construction of the space diagram. The first question was to determine our reactions RE and RB. And this determination was to be done graphically using drawing procedures throughout. It can also be done analytically, that is by mathematical method. But using the drawing method, we have to first and foremost convert these forces or this load up here, which is 15 newtons, in our polar diagram. You have to represent them in our polar diagram. So this 15 newtons is given by JK. This JKL and the letters and the numbering on them is what we call the Ball's notation. So 15 newtons, which is JK, is represented by JK on the load line here. But this is newtons, and we cannot represent it on the load line just like that. Scale has been given as well. 1 mm is equal to 0.5 newtons. So we convert JK 15 newtons also into millimeters. So 15 newtons into millimeters according to the scale 0.5 newtons will be 30 millimeters. So JK is 30 and KL represents this load will also be 30. Now let me give you one clue in solving some of these questions. When you look at the truss, you could see that it's symmetrical, meaning when it is divided into two equal halves, what is here is the same as what is here. As soon as that happens, you should get a clue or the understanding that the reactions at the various ends, if it's a simply supported beam, will be the same. You should know that the reactions RP and RQ will be the same because according to the truss, it will be symmetrical when divided into two. That is the first clue. But we don't know how the value for the RP and the RQ. That is what we are coming to look out for. But the point is that the values will be the same. So we represent JK, which is 15 newtons per our scale, at this side, JK, and then KL also on the load line KL, because these are the two loads that we have. Now, we make a polar point. This polar point is actually a distance of either 40 mm or 50 mm from the load line. If in the question it is not given, you have to use a reasonable distance, polar point, away from your load line, which is 40 or 50. And in my case, I used 40. So the whole of this line, you can make a point on it at anywhere, but I chose this point. As soon as you make this point, you label it O, you join J to O, and then you join K to O, you join L to O. Now this polar diagram is what is used in drawing the funicular polygon. So JO here is transferred para into the space diagram. In this space JO. The same thing applies to KO. So we transfer KO para to each space KO. And we have LO on this side. You transfer it also in the space diagram LO. Now you joined J to L with a short dashes line, and this is the closure. You take the closure back, transfer with the help of set squares back to the polar diagram. And then what happens here is that the closure line with the short dashes will lie on the same line with KO. It will lie on the same line with KO. And that is a fact. So when it lies on the same line with KO, you label it M. So at that point, we are going to have K, we are going to have M, all on the same line. So when you transfer this with your T square, transfer G, you transfer L. From M to G is the reaction RP. And from K to L is your reaction RQ. This measured by, or when measured, will give you 30 mm. This one will also give you 30 mm. That is the reaction for RP and RQ. I told you they're going to be the same, and we're having 30 mm, 30 mm. But since they are reactions and it should be a force, we have to convert it back to force. So 30 newtons when converted to the force according to the scale, 0.5 newtons is equal to 1 mm. You're going to get 15 newtons. You're going to get 15 newtons. So the reactions, that is RP, RQ, will be 30 millimeters, 30 millimeters, which is 15 newtons and 15 newtons. So this is how come we got the reactions RP and RQ being the same. In the next video, we'll move to determination of the polar diagram.